Now, carrying with our syllabus further, we have to see now transpose of a matrix, symmetric matrix, skew symmetric matrix, orthogonal matrix, conjugate matrix, Hermitian and skew Hermitian matrix. Let us start with your transpose of a matrix. Let us start with this. Now, suppose you've got a matrix A, which is of the form 3 cross 2, that is 3 rows and 2 columns, that is 2, 3, 4, 5, 6, 7. Then the transpose of this would be A denoted by A transpose in some books, and some books they use this. I will use this. So A transpose, this row will become column now. 2, 3, 4. This is what? 3 cross 2 matrix. Now this will become 5, 6, 7. 5, 6, 7. Now you have seen that this has become now 2 cross 3. Again you take a transpose of this. A transpose, you're taking the transpose of this matrix, not this one. You're taking this. So this will now again become 2, 3, 4, 5, 6, 7, which is same as the original matrix. Now, this is what I wanted to show you by taking transposes. Now, what are the properties of transpose? We are going to write down and we are going to understand them. Very simple. The properties of this transpose. Now, the first property. Now, A plus B whole transpose is equal to A transpose plus B transpose. Suppose there is a minus sign, the minus sign will come here. That's all. 2. K A transpose. So this will become K A transpose. K is some number like 5, 6, 7, whatever. Some number. Okay, now the third one. Third one is very, very important. This is AB transpose. This will be B transpose, A transpose. This is also known as reversal law of transpose. Transpose. Now basically we call it the shoe socks rule at times, just for some sake of change. Because you people first wear your socks, then your shoes. While removing it, you remove the shoe first and then you take out your socks. That's why. This is just some change for from the original. This is the original. This is just for the sake of some pleasure, whatever. Now, if you do 2 times transpose, you take a transpose, again you take a transpose, you will get back this. The way I showed it here. I showed it here. This was complete A matrix. Now with this, the transpose is over. We will now come to symmetric matrix. Let us understand what it is first. What it is first. Now this is symmetric matrix. Let me drag it little down more so that we get more page. Now let me draw a line. Wait. Let me draw the line. Now in symmetric matrix, let us understand. Wait. Just a minute. Symmetric matrix. Let me write this a little clearly. Symmetric matrix. Now, you have a matrix A. I have already told you what is the principal diagonal in my earlier lecture, earlier video. Now you write anything here of your choice, 3, 4, 5. Now this is the position, this is A11, this is A22, this is A33, this is A13 position. Now let me write down something here first. First I write down in this fashion. A11, A12, A13, A21, A22, A23. Then A31, A32, A33. Now these are your diagonal elements. I have already earlier told you that these are your diagonal elements. These are your principal diagonal. I have already told you in my earlier video. Now you write whatever you want to write on the principal diagonal. Now remember, whatever you write here, you should write the same here. That is, suppose I write 7 here, you should write 7 here. If you write, this is the position A13 and A31 will be same. You write a 5 here. No, let me write a different letter. 6 here. Wait. Let me write 6 here. Then this is A13. This is the A13 position, and you will go to A31 also, you write 6. Now A23 will be same as A32. You write something, say 9. Then you write a 9. This is a symmetric matrix. This is how you should create a symmetric matrix. Now I'll tell you the rules and other way of creating the symmetric matrix. I'll tell you the exact. Now see, if you take the transpose of this matrix, take the transpose. Now this row will be written as column 3, 7, 6. Now this row will be written as column 7, 4, 9. And this row will be written as column 6, 9, 5. Can you see any change? No, they are both looking the same. So A transpose is A. That's why this A is a symmetric matrix. Now I'll give you the theoretical. I give you an example. Now I'll give you the theoretical. For symmetric matrix, the first condition is that A transpose should be A. That is, Aij is equal to Aji. That means here, if I look into this example, this element is same as this. So A13 will be equal to A31. Then A21 will be equal to A12. Then A23 will be equal to A33. That means the off diagonal elements will be that way it will be same. That is, Aij should be equal to Aji. This is the idea behind symmetric matrix. This rule you must follow while designing a symmetric matrix. Now let's see a skew symmetric matrix. Let's see a skew symmetric matrix. This is skew symmetric matrix. Now, see one thing. In this case, A transpose will be equal to minus A. Got the point? And Aij will be equal to minus Aji. Now, how to design it? Very simple. You write A, any matrix. On the principal diagonal, write zeros. I'll just explain you why the zeros will come. And whatever you write here, put a minus of that here. You write 7, you write minus 7. If you write minus 7 here, then you write plus 7 here. That is the way. You write a 6 here, you write a minus 6 here. You write minus 4 here, then you write a 4 here. Take the transpose. Take the transpose. I'll tell you why these zeros are coming in the principal diagonal. Wait a minute. A transpose is equal to 0, 7, 6. This row has become a column. Now this row will become a column. 7 minus 7, 0 minus 4. Then this will become minus 6, 4, 0. Now take a negative of this. Find minus A. Minus A would be just multiply with minus with every element here. 0 minus 7 minus 6, 7, 0, 4, 6, 4, 0. Now can you see this is same as this? So A transpose is equal to minus A in this case. This is the crux point of this picture. That's why you saw it in an example. Now I will tell you why these are 0. Now see why these are 0. You will right now see why these are 0. Wait. Let me get some page for myself. Yes. Now see, wait a minute. I told you in this case, A transpose is minus A and Aij is minus Aji. I told you this. Now for the case, in the diagonal case, for diagonal elements, we know I equal to J, because those elements are A11, A22, A33, that's why. So Aii from this equation, Aii is minus Aii. Bring this here, Aii plus Aii equal to 0. So 2Aii equal to 0. That means Aii is always 0. That's why all the diagonal elements are, that's why you see All the diagonal elements are, wait a minute, it went very fast. Wait. Yeah, that's why all these diagonal elements are 0. That's the reason behind it. I gave you the reason now. Now the next is complex matrix. Now we will see something called transjugate matrix and orthogonal matrix and all that. Let's see orthogonal matrix. Orthogonal matrix. Orthogonal matrix. Now in this, the first thing is that A transpose should be equal to identity matrix is equal to A transpose A. Sorry. Now A is A11, A12, A13, A21, A22, A23, A31, A32, A33. Now if you take the transpose of this, that is A11, A12, you write the row in the column fashion. A13, A21, A22, A23, A31, A32 and A33, and you multiply A transpose or you multiply A transpose A, you should get an identity. If you get an identity, that means if you get this, then A is orthogonal. Just a minute. Wait a minute. A is orthogonal. If this condition holds. One more way of this is if you multiply, I will show you something. If you multiply this row with this row, or this row with this row, or this row with this row, or this row with this column with this column, and this column with this column, you will get 0. I am showing you. Wait. First, I'll show you the row. Let me write it here. You will get some idea. If I write row A11, A21, A12, A22, A13, A23, I should get a 0. Or if I see column wise, this is row wise, row wise. This was row wise. Now column wise, A11, A12, A21, A21, A22, this is 2. Wait a minute. This is A22. A1, A23, it is this 2. Now this is A21, A22 plus A31, A32. This is column wise. So this is 0. Column wise. This is an orthogonal matrix. Now we will see a transjugate matrix. Before that, I'll show you something. Because you people, most of you, we didn't have maths in 11th and 12th. So according to the syllabus, you need to know what is complex number. Then only will you understand this. Now let me draw a line. Wait. Let me draw a line. Wait. Wait. I don't know why the line is not coming. Wait a minute. Let me check why the line is not coming. Yes, the line is here. Now, you have seen in class 10th, this is 10th, this is your coordinate axes, x and y. This is your first quadrant, you used to write x comma y. This is your second quadrant, minus x comma y. This is the third quadrant, x comma minus y. And this is your fourth quadrant, x comma minus y. Now I'll tell you something called iota. Iota is I, which is has a value -1. I don't have to go into details. I square, taking Square both sides. I square is minus 1. I cube is multiplying both sides again by I. That is I square into I. And it's minus 1 into I. You will get I cube is minus I. Now you have I cube into I is equal to minus I into I again. This will be minus 1 and there is a minus. So this will be I4 is plus 1. Now this was what you knew in class 10th. Now you will write this very thing as, now look, I will pull it little down. I'll pull it little down. And the very thing you will write it as now. This x comma y. Now this will be a real axis. And this will be imaginary axis. No more x and y axis anymore. This is x and y. This is can be written as x plus I y, where I is the iota. This was what? Minus x comma y. This is to be written as minus x plus I y. This was minus x minus y. This is to be written as minus x minus I y. This was x comma minus y. Now this is going to be written as x minus iy. This is how you will correlate the complex numbers. Now this is no more a coordinate, but this is a complex plane. That was the coordinate plane and this is the complex plane. Now a complex number is denoted by z, that is x plus iy. This is the way it is denoted. The conjugate of this is the conjugate z bar. This is called z bar. Z bar, and this is the conjugate of z. Now z bar can be written as x minus iy. Whatever is the sign before this y, before this I, you have to change that. Now let me tell you, I'll make the thing more clear to you with some more. Let me have some space. Yes. If z is x plus iy, the conjugate is z bar, that is x minus iy. If z is x minus iy, the conjugate is z bar x plus iy. Now z is minus x plus iy, the conjugate is z bar, and that is minus x minus iy. Now z is minus x minus iy, then the conjugate is z bar is minus x plus iy. This is the way you have to change the sign before iota. This is the idea. Whatever, just change the sign before the iota one. This is the idea. Now let us see what is a transjugate matrix. Let us see what is a transjugate matrix. I think I'll discuss it in the next chapter, next lesson. Let's stop it here.